Okay, hallo und willkommen to Streamlining Manufacturing Reports at the Volkswagen Group. Today I'm joined on stage with Dennis Kämmerer, Daniel Lütke-Hermölle, and Michele Lamarca from the AWS Data Lab team. You'll hear from them over the next 45 minutes in this session. My name is Sebastian Collins, and for the last 4.5 years, I've been working in the AWS Solutions Architecture team, looking after everything related to Volkswagen Group. My main focus has been on the AWS foundational landing zones. These consist of more than 10,000 AWS accounts throughout the AWS group, throughout the VW group. Some of them are what we call the basic platform landing zone, which hosts business critical applications and things like the Cloud IDP. We also have the serverless only landing zone, which is used by the software development centers where they build the global procurement suite. And of course, the managed platform services, which is a highly regulated and secure landing zone used at the Volkswagen Financial Services, where we've scaled their environment by more than 600% over the last 5 years. I also get to enjoy working with some of the best teams within the group, the national sales organizations in Germany, France. I also get to work with the software development teams in Hannover and Lissabon, and of course the lovely IT city in Wolfsburg. And one thing I have found from speaking with all these customers and talking to all these different teams and looking at their applications is that deriving insight from data is hard. And it is even harder when your organization is dealing with silos that impede data access, create distance across systems, and don't meet the people in the organization where they are in terms of needing data. And typically, customers have 3 problems. One of them is the data silos. Data silos make connecting data lakes, data warehouses, and other analytics data stores very difficult. People silos make it hard to expand access to data and analytics to business users, analysts, end users, and decision makers. And they are business barriers. These make it hard to balance the cost and manage legacy systems. So today, we're going to walk you through how Volkswagen Group built better reports from analyzing their environment to finding a solution and then finally deploying it in their factories across the world. First, Dennis will walk you through some of the project background, some of the background of Volkswagen Group and their specific use case that they needed to discover. Then Michele from the AWS Data Lab team will talk you through how they started the project planning and how they set up the environment to get started on this use case. After that, Daniel will talk about the building phase, and he's really going to talk about the architecture. He's going to go in depth and explain to you each and every component that we built during the Data Lab engagement. He'll also share some valuable lessons learned, some paper cuts, some things that didn't work so well, some things that worked really well. And then lastly, I will talk about how the Volkswagen Group will continue to scale this environment through all the factories, describing the process of implementing, packaging, and deploying this across the group and their factories. With that, I'd like to welcome Dennis to the stage.
Yes, thank you, Sebastian, for this nice introduction, and welcome everybody from my side as well. My name is Dennis, and I work in the Software and Development Center in Hanover, which is part of the Volkswagen Group. When I talk about the Volkswagen Group, some of you probably know, I'm not only talking about VW as a brand. The Volkswagen Group includes many other brands such as Porsche, Audi, Skoda, Seat, Lamborghini, and other brands as well. And the project we are taking care of is a group project, which means this solution will be used by a lot of different brands worldwide. Let me give you some more project context to give you a better understanding. First of all, our solution is part of the so-called FIS system. FIS is a German acronym, stands for Fertigungs-, Informations- und Steuerungssystem, freely translated in English, something like Factory Steering and Information System. FIS is currently used in more than 40 plants worldwide, and as I already mentioned, different brands. And due to the fact that the system is quite a few years old nowadays, it's an on-premise solution, which means each and all plants have their own server and their own FIS instance. And the initial reason why we started this project was basically because the reporting part of this solution will be end of life by 2027. So we had to renew it to bring a new reporting solution. And to give you a better understanding of how this legacy, how this old system looks like, let's have a quick look at the next slide. So on the left-hand side, you can see that we have a source database in our factory, the FIS source database. So during the manufacturing process, we collect a lot of data from the machines and from the cars and store them in the source database, because we need this data to steer different processes within the factory. And based on our source database, we have our reporting database, which actually has 3 parts in it. First of all, we have a one-on-one replication from our source database, so the raw data. Secondly, we do some historization, and of course, we do some data preparation to make it easier for the data analysts later to build reports with the data. And this reporting database is then the source database for the BI solution in the plant. So the data analysts, the business analysts can actually build their own data products, build their own reports, and share them with different departments. So when we received the task to build this new solution, we could go different ways, of course. So there's always this easy lift and shift solution, right? More or less rebuild it and put it on another platform. But that was not the way we wanted to go. We really wanted to understand what is the demand in the plants. So in the beginning of the project, we conducted a lot of interviews with the users in the plants, and of course we did some research. And we figured out that there are 5 main challenges with the current legacy solution. I mean, it's probably not really a surprise, but one thing which is definitely not really a good solution right now is that there are only very few cross-plant synergies, because everything is a restricted on-premise solution. So it's very hard to exchange data in between the different plants. The second challenge was definitely about the maintenance of the whole system, because everything is on premise. The reporting solution was a third-party provider, so it was pretty hard to provide updates in a short period of time if the plants actually needed some new functionality. And that directly led to the third challenge here. So due to the fact that they needed some functionality which was not provided, they started to build workarounds. And I think we can agree that it's not really a good solution if each and all plants build their own workarounds for specific use cases. The fourth thing is about the on-premise hardware itself, because an on-premise server is very hard to scale based on the demand. So usually in the morning, the plants generate a lot of reports, so they need a lot of performance. And over the course of the day, they only generate a few reports, so they actually don't need that much performance. Which means in the morning, actually they would like to have more performance. Over the course of the day, they still have the same performance like in the morning, which is not really cost efficient if you don't use it. And the last thing is about the reporting itself. So the plants really told us, okay, our solution is quite old now. There are much better and more modern BI solutions on the market. Can you can you bring a new solution here with nice drill down functionalities, nice filter functionalities? And this is definitely a challenge we took with us. So based on these challenges, we had to decide what can be our next steps. And I think, again, it's not a surprise for you. We wanted definitely to go into the cloud. And we had 2 benefits here. The first benefit was that there's already a cloud platform for the Volkswagen production part in place, called Digital Production Platform, and is based on AWS. So for us, it was clear we will develop or we will build a new solution with AWS services. But if you have on-premise server, of course, you need to bring all this data into the cloud if you want to work with the data in the cloud, right? And here we had a second benefit, because with another team in the Software and Development Center in Hanover, we were able to replicate all the data from the on-premise servers into the cloud. So we are, with our reporting project, able to use this data in the cloud. The second part was actually the most complex part then, because we had to bring all the functionality and all the technology to get data insights into the cloud. And I think we really found a very nice solution here. And my colleague Daniel will show you in a few minutes our new architecture and go a little bit more into technical detail of how we achieved it. The third part was then about renewing the reporting solution, and to be honest, with AWS QuickSight, we found a very nice solution here to build and to provide a state-of-the-art business intelligence tool with nice filters, drill downs, and just a modern look and feel. The fourth point you can see here is something which is currently ongoing. So our vision is we want to provide a centralized data catalog. So each and all plants can actually gain data insights into their data and exchange their data products in between all the different plants. As I said, it's currently ongoing. Maybe we will be back next year and we can talk about this as well. So when we had our next challenges in mind, we had to decide of how can we do it. And in the beginning, we really did a lot of research and had a look at the different AWS services. But pretty soon, I thought it makes sense if we go in touch with our AWS account manager, and we did that because I just wanted to know what would be your recommendation. And AWS offered us a so-called data lab to build a proof of concept, and we really achieved a nice result out of it. So I would like to hand over to Michele now, because he will tell you more about what is a data lab and how you can benefit from it. Thank you very much.
Thank you, Dennis. Good afternoon, everyone. So I'm Michele Lamarca. I'm an architect with the AWS Data Lab. And I know you're all eager to see the architecture, what has been implemented by Volkswagen team, but let's talk a little bit about how we get there and what was the planning part. I would like to start with a personal kind of story. I like music, specifically piano music, and you know, piano music is on paper, but if you don't really hear the music, there's not much that you can understand from the piano, from the sheet. So what I also do, I try to practice. I don't practice a lot. Indeed, I'm not playing at the concert house tonight, but I have a career in IT. But besides that, I understood immediately, if I want to improve my piano skills, I need to practice. I also probably need the guidance by some teacher, because someone needs to tell me where to focus my energies. And how can I relate this to data initiatives on AWS? We have services, we have solutions, but if you want really to become proficient and achieving your business goals, you need to practice. And you also need guidance from someone who has also experience in AWS services like us Data Lab architects. So I think this brings me to the one of the most important principles of Data Lab. We know that, and this is also what we learn from experience with you customers, is that you customers learn when you do the work. So we can show you what to do, but it's even better when we guide you doing things and you actually implement things in your environment. Having said that, I would like to spend a few more minutes about Data Lab. So let's start with why. We help customers implementing their solutions because, as I said, we have many services. Customers also need guidance. They need to know where to combine all the services to get to their business goal. And we remove roadblocks, and also what we do, indeed, we provide guidance from us and also other experts from AWS. We live in the land of prototypes. So what we do with customers is a joint engagement. It's either a design or a build lab. In the case of Volkswagen team, we decided to go with the build lab. Build lab entails that the builders from Volkswagen, they implemented the architecture that Daniel is going to show in their environment. So as you as a customer will use your builders and you will create your architecture in your environment with your data. So you will see immediately the business benefit of what you're doing. We see that in some cases it's not the ideal fit for our customers, but in some cases, like for Volkswagen Group, was a really good fit because what we start with is always a clear business case with an intention to go in production because it's a strategic kind of activity. Again, if I want to summarize what we do in Data Lab, we work together with the customer, but we work to accelerate the customer journey to the cloud. We work together with the customer, but focusing on a specific business goal. Let's see exactly how we work together with Volkswagen. In Amazon, we have this concept of working backwards approach. We start first with the problem, and then we get to the technology. So in our engagement with the Volkswagen Group, what we did, we executed a build lab. We had a few weeks of preparation, and then finally we got our hands dirty, especially the builders from the Volkswagen team, and they went and implemented the architecture. But again, we start with the business in mind. So what is the business objective? We need to take into account the KPIs and create BI dashboards. So this is how we can translate then the business objectives in getting insights on our production plant. And how we do that? We need to translate this into technical objectives, meaning we need to bring the data from the sources to AWS. Then we need to create reports, we need to create the data products. So slowly we are moving to an actual technical implementation. If we translate this into lab goals, it means creating data pipelines, for instance, creating also reports, creating connection to the databases. So the focus then shifts really to what are we going to achieve during the execution of a lab. So we work on scoping the prototype because we need to build a prototype which brings business value, but is really working because it's on real data. So we focus on scoping the prototype, which will be executed in 4 days, where the builders from the customer side will implement the architecture that we have agreed upon. During these 4 days, which are quite intensive because it's really a small compressed kind of sprint, we also do a demo. The customers do their demo so they can show their stakeholders the value of what has been produced. This is also what we did indeed with the Volkswagen Group. After the demo, then we produce a report to explain all the different activities which have been achieved during these days. And this is the path that we took with the group, with the Volkswagen Group team. We have also another offering, which is a design lab, where instead of getting to a prototype, we still start with business objectives, but we end with our architectural recommendation. So this is what we did. And before leaving you to Daniel, who's going to describe the architecture that they implemented, I just want to recall that in Data Lab, we had more than 1,500 engagement with customers. Every other month with an engagement in the automotive sector, so we have acquired a certain knowledge on all our customers, but specifically also on this vertical. And specifically with Volkswagen Group, we did more than 10 engagements. AWS is moving fast, so right now we are not accepting other nominations for Data Lab, but what I encourage you to do is to go to your account team and ask for how AWS team can help you. Having said that, I thank you guys for the attention, and I will pass then the word to Daniel for the building phase. Thank you.
Thank you, Michele. And also a good day to everyone. The Data Lab with Michele resulted in a working prototype that I will now talk to you about in more technical detail. My name is Daniel, and I worked as a software developer throughout the product development. I will guide you through this architecture diagram now step by step, and later I will emphasize on some lessons learned along the way. So let's start at the beginning with the data source. Right now, we face the reality that every plant in Volkswagen Group has its own on-premise database, which is a rather old IBM DB2. And our first task was to bring this data into the cloud. We had already some previous knowledge with migrating DB2 databases, so that was lucky for us. And for this, we used the database migration service. For the prototype, we focused on a single full load first. We had some discussions with the plant ownership of the data, and we wanted to give them the confidence that we are not impacting their database any further than it has to. And so we just didn't do the continuous data change capture, but only worked on a snapshot. Besides replicating the database, we did 2 customizations on it. The first one was we converted all database names, all table names, and all schema names, and basically all identifiers to lowercase. This was not the case in the original database, and we knew that this can create some undesired consequences if you do that in, let's say, modern data analytics tools. The second one was we added a timestamp to every row when we replicated it. This was necessary for the data ingestion later to Redshift. So the Amazon Aurora is a replica of the data source. We use for this an Amazon Aurora serverless v2 with PostgreSQL, and the amount of data was about 30 gigabytes for this rather small plant. Other plants will range around 100 to 500 gigabytes of data. The interesting thing is that after we built this prototype, we moved these 2 things out of our product and let it handled by a different specialized team that focused on just migrating plant data. There are some optimizations in the data that can only be done here, or more efficiently be done here than later in a batch process that we do in Redshift. Now we've got the data in the cloud, and we can utilize Amazon Redshift to ingest the data without having to fear to impact the on-premise system. To connect to the Aurora database, we set up federated queries with an external schema in Redshift. Some might ask now, why did we do the step with the Aurora database in between? Why didn't we just use the DMS to directly digest data into Redshift, which would technically be possible? The one reason I already mentioned is that we wanted to have as little impact on the on-premise system as we can. So we wanted to have a layer of abstraction between it. The other reason is that Redshift is optimized on big batches of data. And a continuous data stream would cause a constant flow on the Redshift database and create more cost than it should. So how did our ingestion then work? A Lambda triggered by a simple event bridge rule, triggered every 5 minutes, copies data from the Aurora into a staging schema. The timestamp that we inserted earlier in the DMS phase was now used to identify new rows and select those rows, and then we used a simple SQL insert to get those data into Redshift. As long as you ensure that you have a proper index on the timestamps in each table in the source database, this is the most efficient way to ingest data into Redshift from an SQL source. Now, the data is ready to be used now, but it's still kind of raw. When business users are supposed to use it, they want to use it in a way as data products provide them. Business analysts can create these with the Redshift's editor v2, which is basically an SQL editor in Amazon. The plus point is that it is easy to understand for everyone who is already familiar with SQL, and it was also very easy to set up for us. It provides data permission and authentication right out of the box when you use IAM. So during the data lab, we focus on creating data products as materialized views in Redshift. In Redshift, materialized views are constructs that can be incrementally refreshed and function as a good way to cache data in different formats. As materialized views can themselves be the source of other materialized views again, we can create a complex ETL scheme with this. In the end, the humans have to understand this data, and they want the data in pie charts and bar graphs and so on. And the easiest way to do that for us was just using Amazon QuickSight. A data product with a materialized view, as I said earlier, can be used as a source for a data set in QuickSight. And by setting up these data sets, we make it easy to understand and to use for business analysts and business users alike to create reports and dashboards out of it. Lastly, to ensure the quality of our data process, we also set up a monitoring. During the data ingestion, the Lambda function creates 2 metrics for that. One metric has one of the stored procedures that the Lambda calls, has it failed or has it been successful? And the other one is, how long did each of these stored procedures take, and how long did it take to refresh or create a materialized view? So we created CloudWatch dashboards from it, and also some notification system for our developers. And as soon as any of these data products takes longer than it should, or than it is anticipated, we know as soon as possible and can help the business analysts or business users with optimizing this. So, while building the prototype, we learned a few things along the way. The first and most important thing was the data lab itself. It was really good to have someone who knows all the different products in AWS that help with data analytics. There are just a few out there, and we struggled to find the best one. We tried out with Glue and Kinesis and Aurora and also on and Data Pipeline, and Michele and his team helped us to gain the confidence that our approach was the right one now. The data lab supported us even after the lab. So after I knew Michele's email address, I could hit him up every now and then a few weeks after the data lab, every time I hit some roadblock or I needed some advice. As much as this data lab helps, the grunt work has still to be done by the developer team. And they need a solid understanding of AWS and a solid coding knowledge to be able to be effective in such a data lab. The faster you can serve new prototypes each day in the just 4 days of the data lab, the more the data lab can help with roadblocks. Having, for example, a CI/CD approach at the beginning helps a lot with that. A good example was that initially Michele and his team walked us through step functions to trigger processes in Redshift. But we came to the conclusion that this approach was far too complex for us, and later we just tried a simple Lambda that was triggered by an event bridge rule. If we had a CI/CD pipeline in place, then we could just have deployed both of the approaches simultaneously and compared them far more quickly than we could without. And that would have given us time to work more on features. I already talked about the outsourcing of the replication. We outsourced the replication during a few days after the data lab because it was more work than it seems. It's not just a DMS task to replicate the database from the on-prem system. The DMS task already streamlines that a lot compared to some other techniques to do that, but it's not enough. One of the downsides of DMS or CDC replication in general is that you need vast permissions on the data source itself to read the transaction log. A lot of work went into proving to the plants that we don't fuck up their databases. So the plants, as the owner of the data, wanted to be in control of who reads which data at what point in time. So we had to provide a good architecture and an architecture for authentications and permissions to satisfy that need. We also needed to, the plants also wanted to be in control of the replication itself. So we had to provide them something like a kill switch and a monitoring that they can see what we are actually doing with our replication. So this is why we decided to outsource this to another team who just specialized on that. So not only the technical part, but also the politics. Since we rely heavily on CDK for our CI/CD pipelines in the Software Development Center in Hannover, where I work, we found out that there is limited support for Redshift and QuickSight. Some of the features are still in alpha stage, and some features are just not supported. The examples that were most relevant for us were key rotations in Redshift users and IAM management in QuickSight. The good news for us is that CDK is open source, and we are able to build these constructs ourselves if we need them to. And later we might even be able to contribute them back to the CDK community. We struggled specifically with Redshift in some other ways. Redshift is not your good old database management system. It is just a data warehouse that happens to have an SQL interface. This is the huge selling point of Redshift because it's easy to use for anyone who is already familiar with SQL, but the Redshift database behaves slightly different than you are used to. For example, alias names, are not a thing in Redshift. We try to use views for aliases, but they are not allowed to be used inside of materialized views. So we had to take care that we rename all the tables to the name that we want to during the data ingestion itself. There are also no trigger functions in Redshift, which you should know from SQL databases. To be able to get a trigger functionality, you have to use the Redshift Data API to get the same result. Redshift is really, really fast with large sets of data, but at the same time, it's very slow if you run a lot of small queries at it. So you have to design your queries a little bit differently than you're used to from an SQL. If you have a lot of small changes that you want to do on a data set, rather do it using the DMS beforehand and not in the Redshift. Use Redshift for what it is made for, namely transforming big batches of data into other formats. Lastly, I also already mentioned our struggle with AWS step functions. As I mentioned, we started the data lab with using step functions to orchestrate the data ingestion. Step functions are a great tool to orchestrate complex systems, but in the end, we just had one Lambda that handled the data ingestion. So we just used a simple event bridge rule to handle that. So my last advice is before you start going into step functions, just think about how complex your tasks in the end really are. I hope I could give you some insights now, and our product evolved already from this prototype, of course, but we learned and adapted along the way, and the AWS Data Lab really gave us a very good impulse to start away. So thank you. So now I will let you wake you up from my colleague Sebastian.
Thank you, Daniel. I appreciate that. So now that you have seen the architecture in a little more depth, how do we scale this across 40 plants that Dennis spoke about earlier? To do this, we need to use a modern data architecture that can handle the enormous growth now and into the future. Harnessing data to its full potential requires a complete end-to-end solution to store, access, analyze, visualize, and predict. So in order to do this, you will need a database to store and process data that power your applications, to unite all the data generated from applications, as well as data that you might have stored in different places. You will need a data lake. To move data, you'll need tools to transfer it, something like DMS, for example. To unlock insights from your data, you'll need analytics and visualization tools. And then to go beyond insights to predictions, you'll need to use AI and ML to build models and add intelligence to your applications. And finally, for any of this to work, you need to make sure that you have security and governance in place so that you can put the data in the hands of the people at all levels of your organization. So back in 2018, Volkswagen Group and AWS started working on a solution to this. By working with VW at the highest levels, the now chairman of the board of management of Volkswagen and Porsche, Oliver Blume, said that we will continue to strengthen production as a key competitive factor for the Volkswagen Group. And to do this, AWS and Volkswagen developed the Digital Production Platform. So what is the Digital Production Platform? The DPP is a cloud initiative focused on accelerating the connectivity and optimization of production by plants by providing a common set of shared services, including plant device connectivity, data management and governance, as well as integration with existing systems and suppliers, through a platform that spans AWS and the on-premise environment. The entire platform is built in a few layers. Layer 0 is the factory layer. It ingests data from tens of thousands of machines from the shop floor across 125 factories, including the 40 that Dennis was speaking about earlier. Then, layer 1 are the AWS services themselves. These allow the DPP builders to make use of AWS's service portfolio, developing at scale. This allows them to use services such as Amazon Managed Streaming for Apache Kafka, AWS IoT Core, or DMS to ingest data at scale from the edge to the cloud. But of course, it's Volkswagen. So with layer 3, you bring in the DPP platform services. And these are a set of microservices that build and are packaged entirely on AWS to meet the IT requirements of Volkswagen. These are then used to enable business outcomes at scale across the entire Volkswagen Group. Think about how when they were outsourcing the data to a different team. This is where the layer 2 sits. And then finally, layer 3. This is the Volkswagen Group application portfolio. And here you can see the Fizz BI reporting. These are completed use cases that can be reused over and over again at all the different factories. And you can simply go to a shopping cart, select the product, and deploy it in your factories as needed. So with the goal to improve production efficiency by 30%, while reducing cost by 30%, some of the benefits of the DPP are already onboarding entire plants using shared and standard solutions that enable the builder community at large. And secondly, they provide core assets in the form of microservices and blueprints to allow VW businesses to quickly deploy ready-made solutions across the DPP. And so with AWS, you can execute this modern data strategy. This gives you a comprehensive plan to manage, access, and analyze, as well as act on the data that you generate from your factories. A modern data strategy gives you 5 things. It unifies the data and breaks down the barriers between data silos for your analytics of all your data. AWS also offers the highest price performance without sacrificing scale. It allows you to connect analytics and machine learning system by making it accessible to as many people as possible, as easily as possible. It unifies the data access, security, and governance into one pane of glass for all your analytics workloads. And of course, lastly, it enables insights for everyone. Thank you very much. My name is Sebastian Collins, and I'd like to thank my colleagues, Michele, Dennis, and Daniel. If you want to learn more about this, please feel free to email us, talk to us on LinkedIn, and please be sure to fill out the survey as well. Thank you very much for your time.